Hello everyone. Today we are going to solve question number 206, reverse linked list. This is going to be our first video on linked list. Okay, so we are also going to define what a linked list is. So the question demands us that given the head of a singly linked list, reverse the list and return the reversed list. So let's discuss what a linked list is. So basically, it's a data structure which stores any type of variable, a data, and the pointer to the next value to this data. Okay. So as the name suggests, a linked list. So basically a list that is linked to each other through pointers. Okay. That's simply a linked list. Okay. So to reverse a list, we are going to see 2 to 3 approaches in this video. Okay. So first one is going to be a brute force approach. First thing that comes in our mind is we can store these variables or the values inside an array or a stack, and then we can just override the values inside it or create a new list according to the reversed order. Okay, that's the first thought that comes in mind, and that's going to be brute force approach. Okay, so there's no pointer manipulations here. We are directly going to store all the list values inside an area stack. A stack is a LIFO following a LIFO property following data structure. Okay, LIFO means last in, first out. Okay, next we'll reverse this array if array is used, or if stack is used, it's already in the format in which we have to push the values, and then we are going to initialize a new head and tail for the reverse list. We'll fill for head and these 3 steps. Okay, these 3 steps are major. Create a node, connect it with tail, and move tail. This is for the part where we are creating a new list rather than updating this same list. Okay, so if you are creating a new list, you have to follow this step 3, or else you can directly fill the values from this reversed array or stack inside this original list. Okay, and in the end you have to return the new head or the head if you're using this directly linked list. Okay, so this is going to be a visualization part for it. This is for creating new one. Okay, so you can see we had this linked list, we stored it inside this array, and then we reversed it. Okay, so it looked like this. This is for stack 1. If we push the values inside the stack, 1 is going to be at the bottom, 2 is above it, 3, 4, 5. So if we use stack, we can directly use the values from top to bottom as we access the values in stack. Hence, we all automatically get a reversed part. Okay, so there's an overhead here that we have to reverse it. Okay, other than that, if we are creating a new list, we'll create 5, then we'll create 4, and we're going to connect it with 5. The 5 is going to connect with 4, and so on and so forth. This is for new creation of list. Okay, so let's solve this one. So I'm not going to create a new list, rather I'm going to use the same list. Okay, so first thing we'll need is, let's list node star temp is equal to head. This is going to help me iterate over this linked list. Okay, one thing that we'll need, so let's iterate over it, and we also need a vector to store. Okay, so vector, and I'm going to name it as st. Okay, next we'll iterate over this list. So while temp is not equal to null, st dot push back temp of value. So in this way you can access the value inside the structure, temp of value, and then you are going to move temp to the next value. So temp is equal to temp's next. Okay, so this line is going to move to the next linked list node, and this line is pushing the values inside this array. Okay, next we'll have we're going to need to reverse this uh, array so that we can rearrange these values in the reversed order. Okay, so reverse, I'm going to use stl over here, reverse uh, st dot begin comma st dot end. So these are this is going to reverse my list. Next, I'll reinitialize my temp because I don't want to make another variable or another pointer. So I'll remove this temp to the initial head. Next, I'll update the values inside this same list. So while temp is not equal to null, so temp's value is going to be st of I. Okay, and I'll also need an I. So int I equals 0. Okay, int I equals 0, and we'll move our temp. So temp is equal to temps next, and we'll do an I plus plus so that we can iterate over this reverse array. Okay, and in the end we can directly return head because we have not created another list. Okay, so let's run this. The time complexity for this one is of n, and space is also of n because we have used another array or a stack. Okay, let's submit this. So you can see we have solved this question using brute force approach. We can also use a stack in this place. Okay, and if you use a stack, the only change is going to be you're going to use push in place of pushback, and there's no need for iteration using I, and you don't have to reverse anything. Okay, so that's it. Let's move on to the next method. So now we are going to move to a recursive approach to solve this question. Okay, this method is going to take a time complexity of O of n and space complexity of O of n because of recursive stack. It's not because we are using an extra space, rather, it's because the inbuilt recursive stack that we are storing inside a RAM. Okay, so let's see the recursive approach to solve this question. In the previous method, we used another data structure to store these values and we reversed it. Okay, this time we'll store a previous list and we'll reconnect nodes pair by pair. Okay, so what I mean by that is, let's see the steps what we're going to follow. Okay, first we'll initialize a current and previous. Previous is going to point to null and current is going to point to the first value. Now we are going to iterate over this list and follow these three steps. First step, store the next of a current to so in variable x. Okay, so if a current is on this position, we are going to store this next list. Second, we'll point the next of this current to previous, and then we are going to increment current and previous. Okay, these are going to be three steps, and we'll do these three steps until our current reaches null, and after current reaches null, the previous is going to be our new head for the list. Okay, so it might seem complex, but it's very simple. So I'll describe you with this visualization where you can see this linked list. So the previous, I'm going to start it with null. Current is going to start from the head. Okay, these are the three steps. First step, you'll need to store the future linked list. Okay, the linked list after this current, you're going to store it because we are going to manipulate this address pointer. Okay, hence we are going to store this list first. Second step, will move this currents next to the previous value because we are reversing. Okay, third part is going to be updation. So we'll move this uh, current to the stored value, the next node that we are storing. The previous is going to move to current. Previous is going to move to current. Okay, so this is going to be okay. So you can see, although you might not feel this has been reversed, but it's actually been reversed. So this is going to be our last node, and the last node generally points to null. Hence, this first node is pointing towards null. Okay, so in this fashion, okay, in the same fashion, it's going to move, and the stopping condition is going to be current equals null. Okay, so you can see for the next one, it's going to move ahead this, and then first for this one, we'll store this. Second, we'll point this to 1, and third, we'll move previous to this part and current to this part. Okay, so this is going to be visualization part, And it's going to look something like this, where each pointer comes and reverse it. Okay. And this is this topping addition, and this is going to be a new head. Okay. So that's for recursive. Let's code this one. So basically, we'll use another list. So let's initialize list node star current is equal to head. Okay. We had a head, a current with storing head. List node star previous is equal to null, or you can say null pointer. Okay. One thing that I want to mention, that if the head is empty, you're going to return an empty list. Hence, I'm going to use this. So if head equals null, I'm going to return null. Okay. So this is this empty case handling. Next, we'll use a recursive approach. So solve previous comma current. Okay. So, and I'm going to store previous is equal to here, because we know that previous is going to be a new head, and then we are going to return previous. Okay. So this part is done. Let's write the solve function. So list node star solve, and we'll need this. So I can directly use this part. So we'll need a previous first. So previous first, then a current. So list node star current. Okay. So as mentioned, 3 steps. First is store. So, and one thing to mention is that there will be a base case. Let me just write a base case. See, okay. Okay. So first step is going to be store. So to store, we'll need a new list node star. We can name it as store. Yeah, that's good. We can name it as store. It's going to store currents next. Okay. Next step is going to be update current, which is going to be currents next is equal to previous. Next, move pointers. So in this point, we have a current connected to currents next connected to previous. Now we are going to move pointers. So previous is equal to current, and current is equal to store. Okay. And then you are going to just use recursion. So recursion. So recursion will be solve previous comma current. Okay. So what do you think the base case is going to be? Is basically you can see here that our stopping condition was if current equals null. Okay. So we are going to use it, that if current equals null. In that case, we can return previous. Okay. We are going to return previous. And so this looks fine. I'll rather store previous. Okay, we have to return this also. Okay, yeah. This is done. This is the base case. If current is equals to null, then we are going to return previous. So let's run this. Okay, let's submit this. Okay, so you can see we have solved this question using recursive approach. Okay, so the third method is going to be almost same. Let's see what's going to be. So now let's see the iterative approach, which is the optimal solution for this question. Okay, so it's basically the same as recursive approach, but the catch is that we don't have to have any recursive stack for this one. Okay, so the space complexity is going to be simply O of 1. Okay, so the iterative approach has almost everything same as the recursive approach, but the thing is that the space complexity for that one is this one is going to be of 1, because there's no recursive stack. Okay, other than that, the visualization part is almost everything is same over here. Okay, there's no changes. So let's directly jump to code this one. Okay. So basically, from the solve, from the previous part, you can see we need a store, we need a current, and we'll need a previous. Okay. So let's define them. First, we'll need a current. So let's node star current is equal to head. Then just node star previous is equal to null pointer. Okay. Next, what we'll do is while current is not equal to null, the same condition as this one. Okay, same condition as this one. While current is not equal to null, what we are going to do is we are going to store the future. So list node star store is equal to currents next. Next thing, we'll uh, update the currents pointer. So currents next is going to be previous. Next, we'll update these, update and move these pointers. Okay, so previous is equal to current is equal to store. Okay, so this is simple 4 lines of code, and next we'll return previous, because in the last case we have returned previous. And here we can also do that is if head equals null, return null, this simply third case handling. Okay, so this is going to be a code. I think everything is fine. Let's run this. Okay, let's submit this. So you can see we have done this question using iterative approach, where time complexity is going to be O(n) and space complexity is going to be O(1). Okay, so that's it for the video. Thank you.